Fire escape engineers inspector summary video. Here we are in Beaumont, Texas. And we've got this nice fire escape here. And a couple of things. Let's talk about the paint. First thing in regards to paint, more rust than paint or more paint than rust. This fire escape has been well maintained and well painted. Not necessarily maintained, but well painted throughout its life because it has plenty of coats and it is older than 78, so it does have lead. So you have to be an EPA renovator in order to scrape and paint this fire escape. That's the first requirement of anybody touching this fire escape. Number two, let's talk about structurally. Fire escape did not pass the confidence test, and I will deal with the three issues, the three codes that we have to deal with. The first code we have to deal with is the NFPA, which is the authority having jurisdiction shall accept by load test. And because this fire escape did not pass the confidence test, we cannot proceed to a load test. Or other evidence of strength. And I don't have other evidence of strength, which would be evidence of maintenance over the lifetime of this structure. I have nothing but original hardware on this fire escape, and a lot of welded connections are original to the building. So I cannot provide other evidence of strength to avoid the load test. Number two, let's talk about the fire code. Fire code says depending on the structural adequacy or the structural condition, a load test may be ordered. This fire escape is old, original to the building, so the only way to get a guarantee is to order a load test. The third one is the building code. The International Building Code says you must examine, test, or certify. The certification comes in the process of refurbishing the fire escape to avoid the load test. So that has not been the case. This fire escape does not show any evidence of refurbishment. It shows all original hardware, whether it be rivets, square head bolts, and machine screws. So let's go down, let's start walking. So we got a lot of rust on a lot of the flats. Some flats have already popped through, creating a life safety hazard that must be addressed. But we got this, see this kind of stuff, a lot of them have popped. So some of them have popped and they're gonna crack along the rust line. So sometimes somebody will step on these and their foot will jam. So that must be addressed immediately. All the treads have been welded, or the original bolts still left behind. Somebody came in, took the bolts out, and just welded. They didn't remove the rust. All original hardware, as you can see, square head bolts. All original welds, and again, not necessarily the best of welds. All welds must be x-rayed or load tested. Otherwise, if you drill and pop a bolt where there's a welded connection, you don't need to x-ray or load test it, and you've basically eliminated the need for load testing. All right, let's take a look at it gets worse as we go down. Same scenario, tiebacks, just general maintenance issues that happen to a building this old. A lot of that has to be all dug out. That's old, probably 25 to 50 years old. Every single tread needs to be rebolted to avoid the load test. Every single one of these needs to be swapped out, and the ones that are dirty. And on this whole fire escape, you're gonna find about 25% failure rate structurally, which is not bad, but no more than 50%. See these machine screws? So screws and square nuts on the back side, but every now and then, whenever these popped, they just welded it into position, but they didn't clean out the rust on the inside. So we're gonna show that. So rust, treads. Some of the treads have so much rust that they ate through the clip. Again, rust here, rust there, so a lot of these have to be cleaned. All that caulking. Jesus, that bug almost got me. All that caulking right here, it's all porous and all just falling apart. Gotta all dig it out and redo it. And again, make sure it doesn't trap water. Let's go down quickly. See, we got water traps here and there. All those must be cleaned, then silicone shots of the water. We're gonna talk about the load test in a second and the through bolt, what needs to happen. But as you can see, some water's getting into some of these. We have to clean those all out. And then once we've sealed them, let's talk about this gusset right here. if the gusset is tight and looks like it has a backup weld, in order for me to not have to load test this, I can put 2 more bolts in here, 2 more bolts up there, keep the original rivets, or keep a rivet, take out 2 other rivets, and basically back up the bolt. But I need to probably size it up 1. But these rivets are a pain to get out, so it's better to back it up with some additional bolting, and you've reinforced the original hardware. If it's in good to excellent condition and reinforced, you can avoid the load test, okay? So let's continue going down. In the upper floors, you've got bigger problems with all your treads than you do in the lower floors. And again, accumulation anywhere. You gotta clean it all out, and then you gotta seal it up with some very good caulking that will adhere cement and steel. All right, let's talk about this time. See those through bolts? That means there's a plate on the inside of this building, okay? They look to be in good condition. I only found a few that I was concerned about, but not to the greatest extent. So these need to be duplicated, and we can duplicate it exactly on the outside with an epoxy bolt. So I will put a reverse angle clip, maybe a 5x5, connect it back to the gusset, and about 5 inches away I would put a new 3/4 epoxy bolt through the veneer and into the masonry block wall, and that way we keep the original, seal it all up, don't let the water get into any of its cracks and crevices. A new epoxy bolt will basically negate the need for us to verify or load test these. That's going to be the standard on all the floors. We got 18 floors, so I'm not going to repeat myself too many times. So rusting along the back, rusting along the major, and some of these are going to pop depending when you're doing an emergency. As you can see, the gussets, the through bolts, some stains. This means that water's getting in. We need to verify that nothing's rotted. But look, some of these treads have severe rot. See, even the clip below is all gone. See, all that's, we got to clean all that out. Replace the clip as needed. Silicone shutter with 50 of silicone. We got to stop the water from trapping in several areas. So, but otherwise, I've only seen a 25% failure rate on this fire escape. But we're going to touch all the, see that? See, that whole clip is gone. So this is a life safety issue. If this clip was to get let go, somebody's foot is going to trap through. See the back? And if this bar back here will pull away, which it might, it'll fall and hit somebody on the head. So we've got some life safety issues on the treads to basically stop the issue for a little bit while we contemplate the full repair of the fire escape. So maybe some reinforcement of some of these more deteriorated treads, clips, rust. Again, it's going to start repeating itself all the way down. So I'll start really going fast. All the bad treads, rust. The photographs will show a lot of dragon tears, showing that water has been getting into some of this part. But otherwise, we've got some good bolts, E-clips at the top and bottom. So some of these staircases, the bottom clip is bad. You know, but as we go down a little bit more, then I'll stop videotaping. But again, 25% failure rate. You know, a lot of these are minor structural, not major structural, such as all these flats. They're considered a minor structural because you just fix these. You don't have to change every one of these rivets. You only change the ones that are bad. The major structural is all the supports, the corner posts, the tie-ins. So this weld I have to x-ray or load test, or put a clip in here, bolt. I don't have to deal with this anymore. So that's the that's that part right there. All right, let's go down one more, a couple more treads, and then we're done. And we'll go down to the cantilever portion of this fire escape. Okay, very bad here. All the treads again. Again, 25% failure rate. Look at that huge accumulation. Okay, huge accumulation. This is typical. But this fire escape, because of the amount of paint they kept throwing on this, she's not that bad. So. Got it? So, even though I got issues, there's nowhere near what I expected to find on a typical fire escape this old. These fire escapes this old, they don't look this good. They have issues, but a lot of these are within the 25 percentile range. Dig all that up, you know, stop all that from happening. There's one life safety issue here on that, and that right is right here, this hole. And this happens. Okay, when the piece falls through, they rot all the way out, So this will happen. Somebody's foot will trap in here, a child or a person, and now they're trapped. They can't get through. They'll break their leg. So some liability. So here's another life safety issue. Aside from treads, we got some flats that are popped on the gratings, and you'll see some of the welds. What they did here is if the bolts stayed, they stayed. If they popped, like these holes popped, instead of putting bolts back in after you clean it, like there, see? Look what happens. There's a good example of what happens. So these bolts, this tread is compromised because I got the one in the back, the rust has eaten the other one, and normally they would come in and weld these, and that's what they did. So they took the bolts out, and then they welded them. This is all the stairs, 100% of the stairs going down are all compromised, and they need to have each one of them temporarily shored so that we can wait. See all the holes on the side? No bolts. Instead of putting the bolts back, they came in and welded. So that's what we have here. And then again, you get the grating flats that are popped through because they rot down the center. So as they rot down these centers, some of them are going to pop through. All right, I'm going to stop here. But even with all this that I'm showing you, this fire escape is only showing it's at least 25%, but no, not exceeding 50% rot. And a lot of these treads, the clips are in very bad condition, meaning they've rotted all the way through. Okay? All right, I will stop here, and now I'm going to go ahead and start talking about the cantilever. Continuation of the inspection here in Beaumont, Texas. So what we have here is now the part that feeds the cantilever. The cantilever is damaged for some reason. So everything that's happened here is everything that's happening up above. The cantilever has the same issues, except now a lot of this is just welded. So in order for me to guarantee that, I have to x-ray or load test that weld, or I can blow some bolts through it, and I eliminated the need. Blow some bolts through these welds here that look good, but to have to avoid to x-ray them, blow some bolts through here, put bolts in these here, put bolts in here, and I don't have to. Now cantilever, she's cockeyed, she's scraping against the building, so she's not functioning correctly. She doesn't go down very nicely, she doesn't come up very nicely. All the treads are the same as above, all original hardware, welded from below, rust in the tops, but there was a hit or a damage in this general area where this thing rests. I think it collapsed. So I think there was a roof collapse of some sort. That I think it's just too much weight on the roof portion. I think we have to create something. Maybe it's going to be very difficult, but we're going to have to create something to take away this pivot point. The entire pivot is resting on that, and it finally gave way. It's crushing this roof, and this roof does not look like it's in great condition. So, and then you have the weight box. That weight box is all rotten. That weight box is just in pieces, and so that's another factor. Look at that. That weight box is ready to give. Okay, so with that being the case, we have to rebuild this whole weight box so that she drops 2 to 3 feet per second, hits the ground, and stays down. But she's got a lot of problems here. So, and you can see the bottom, it crushed. See the crush that happened over there? So she crushed down on that tube over there. So that's what caused it to tilt left. The tube is crushed right there. So that needs to be worked, reinforced back to the building so that not so much weight is on this old roof, and she'll work fine. We're gonna put a release arm on this thing so that right here, when you release it, she'll go down 2 to 3 feet per second, hit the ground and stay down. So that way you can lock it up at a much higher point. So we'll reconfigure this so that she'll lock correctly. When you put it back up, she'll hide up here. And it'll also be an anti-theft device so that nobody can pull it down from down below and break into the building or cause mischief. All right, so as you can see, all the rust. See, welds. This is what happens when something's welded and water still gets in. It eats the rust from inside out. The only way I can do that is I have to clean all these out and re-bolt them back. No welding allowed on a fire escape that has lead. So every one of these, the answer is a bolt. New steel can be welded to new steel, but new steel cannot be welded to old steel. EPA does not allow, so you have to have a renovator's license to touch the paint portion of this, and you have to have a construction license in order to work on the fire escape components. 18 plus stories. Any questions, fire escape engineers? This is Inspector Meneses here. 866-649-0333. 866-649-0333. We're here in Beaumont, Texas.